Hi guys, today we're going to talk about finding and listing factors, and the I can statement we're going to continue to work on is I can find the greatest common factor of two whole numbers less than or equal to 100. And again, we're really going to focus on that word factor. So let's start, before we get into the lesson, and look at how the Cyber Chase kids solved a problem using factors.
What's with the bubbles?
Hey, each of these bubbles has a picture inside it.
And each one has a number.
Number, pairs, find the place.
Number pairs find the place. What's that supposed to mean?
Well, we've got 8 bubbles with pictures and numbers in them.
20, need 20.
20 what?
Maybe a pair of these numbers add up to 20?
But we only have the numbers 1 through 8. There aren't 2 numbers big enough to add up to 20.
Maybe instead of adding pairs, we have to multiply 2 numbers.
But which 2 numbers make 20 when you multiply them together?
I know. 2 times 10.
Hey, you're right, Didge. 2 times 10 is 20. But we don't have the number 10, so it can't be that pair.
How about we make rows and columns of seashells, like we did with the cells? Here's 20 shells.
Okay, but what if 2 and 10 are the only numbers that make 20 when you multiply them?
That's what we're going to find out. We're looking for other factors of 20. Other numbers that when multiplied together give us 20, with no leftovers.
Well, it can't be 3 times 6. You've got leftovers.
Try 5 in a row. Try 5.
4 times 5 is 20, with no leftovers.
Whoa! There's more than one pair of numbers that multiply to 20. Who knew? Let's go to the bubbles.
Pair the numbers, find the place. That's what Manny said.
The pictures must be places. Okay, our pair of numbers is 4 and 5. Bubble 4 is a hot dog, and bubble 5 is a hill.
Hot Dog Hill. Icky must be at Hot Dog Hill.
Are we sure?
Oh.
We still have bubbles 7 and 8 left.
If we multiply 3 times 7, it's 21. And that's more than 20, so it can't be any of those bubbles.
You're right. Hot Dog Hill it is.
So as you see, the Cyber Chase students took the number 20 and looked for the factors of 20. And they said one they didn't list was 1 by 20. They could have made a big long line of shells that was 1 shell long or 1 shell wide with 20 long. They did mention making 2 rows of 10. They also mentioned making 4 rows of 5. So let's look at what that would look like on graph paper. If we were to make rectangles with these factor pairs, we could make a 1 by 20, where I would shade in 1 row of 20 squares on my graph paper. I could also shade in 2 rows of 10 squares on my graph paper, or 4 rows of 5 squares on my graph paper. And if you'll notice, all of these make a perfect rectangle with none left over, just like the Cyber Chase kids were trying to do. All of those possible dimensions represent the factors of 20. Why don't you give it a try? What are the dimensions, length and width, of a rectangle with an area of 24? In the work section of your WSQ, try to make as many possible rectangles out of 24 squares. Pause the video and do this in your work section now. When you're done, hit play. Okay, let's look at the possibilities you came up with. There were several possible answers to this question. First, you could have made a 1 by 24. And on your graph paper, it would look like this. Either one row shading with 24 squares in it, or you could have done this vertically if it did not fit horizontally on your paper. Another possibility you could have had was a 2 by 12. 2 rows of 12 squares. Now, if you had 12 rows of 2 squares, that still works because it's still the same area, which is 24. You could have done a 3 by 8 and a 4 by 6. So there were 4 possible answers to this question because 24 has 8 factors, and each factor has a partner or a pair that makes up the other dimension of whatever number you're finding the factors of. So notice there was a 1 by 24, there was a 2 by 12, there was a 3 by 8, and also a 4 by 6. Try this one. What are the dimensions, the length and width, of a rectangle with an area of 13? Pause the video and draw as many rectangles as you can think of that have an area of 13. Remember, rectangles have length and width with none left over. Okay, let's see what you came up with. For this problem, there is only one answer, a 1 by 13. 13 has exactly 2 factors, 1 and 13. This tells us that 13 is a prime number, and we'll talk more about prime numbers later on in this unit. If a number has exactly 2 factors, we call it a prime number. Let's list all the factors of 30. Now this time we're going to do it without a rectangle. You could have 1 and 30. Then you ask yourself, does 2 go into 30? Yes. 2 goes into 30 15 times. So another factor pair is 2 and 15. Does 3 go into 30? Yes. 3 goes into 30 10 times. So another factor pair is 3 by 10. It doesn't go in 4 times evenly, and I know this because of my divisibility rules. 4 cannot go into 30, but 5 can because it ends with a 0. So 5 times what? 5 times 6. When I make a list of factors, I can think of it as a rainbow, and each pair matches to another factor on the other side of the rainbow. So I go through these questions and I say, does 1 work? Yes. 1 works for every number. Does 2? Yes. 2 by what? 3. Yes. 3 by what? 4 did not, so I skipped it. But 5 did work, and it's 5 by 6. So the next number, what comes after 5, is 6. Does 6 work? Yes, it does, but since it's already on my rainbow, and it's on the other side of the rainbow, I know I can stop. So once I get from one side of the rainbow to the other, I know I've got all the possible factors. Let's look at one more. Let's list all the factors of 40. Well, I start with 1. Does 1 go into 40? Yes, because 1 is a factor of every whole number. So I've got 1 and 40. Notice they would connect if I were making a rainbow. Then I go to the next number. Does 2 go into 40 evenly? Well, 40 is an even number, so I know 2 goes into it evenly. 2 by 20. Does 3 go into 40 evenly? Well, 4 plus 0 is 4, and 4 is not a multiple of 3, so I'm going to skip that. So 3 does not work. It's not a factor. Does 4 go into 40? It does, because 4 can evenly divide 40, so 4 by 10. Then I go with the number after 4, 5. Does 5 go into 40? Well, 40 ends with a 0, so it does. 5 by 8. Does 6 go into 40? Well, if I'm thinking of the rules, 2 works, but 3 does not work. So 6 is not a factor of 40. 7 is not a factor of 40 because 7 times 6 is 42 and 7 times 5 is 35, and there's nothing in between there that is a multiple of 7. So 7 is not a factor of 40. 8 is, though. And since 8 is already on my list, I know I can stop. So if I look at my rainbow, I've got factor pairs on both sides of the rainbow. Now it's your turn to give it a try. In the work section of your WSQ, list all the factors of 64. Pause the video, list the factors of 64, and then hit play. Okay, let's check your work. 1 is a factor of every number, so 1 and 64 is one of our factor pairs. Can 2 go into 64? Well, 4 is an even number, so yes, 2 can go into 64 32 times. When I add 6 plus 4, I get 10. Is 10 a multiple of 3? No. So 3 is not a factor of 64. Then I ask about 4. Can 4 go into 64? And this one you might have to actually divide to figure out. And if you did, you found out that yes, 4 goes into 64 16 times. How about 5? Does 5 go into 64? Well, since it doesn't end in a 0 or 5, I know 5 does not go into 64. What about 6, though? Can 6 go into 64? If I'm thinking of my divisibility rules, it has to work for 2 and 3. But since it doesn't work for 3, it only works for 2, it does not work for 6. So 6 is not a factor of 64. 7 is not a factor of 64 just because I know my multiplication facts, and I know that 7 times 9 is 63, and 64 is just one after that. So 7 times 9 is 63, 7 times 7 is 70, so I've already passed 64, so 7 is not a factor of 64. But what about 8? Is 8 a factor of 64? Yes, it is. And that is 8 times 8. So if I look at my rainbow, 8's partner is himself. So he gets to be the pot of gold in the middle. And so since I got to 8 here, and it's the same thing, and it's 8 on both sides, I've got my pot of gold, I can stop. Let's try another. In the work section of your WSQ, list all the factors of 100. We are done with this video. When you finish this problem, make sure you've written a summary, at least 3 to 4 bullets of the important information that you need to remember about this video. Also, ask a question. If you have no questions, your question might be something to make people think further on the subject. Maybe you want to give the class a problem to try out, but you must have a question in your WSQ. You can go back and watch this video as many times as you need to, or just certain parts.